Hello, this is checkpoint 3.8 from section 3.2. In this problem, they want us to find the values of a and b to make this piecewise function continuous and differentiable at x is equal to 3. So just a note on continuity and differentiability, there is going to be a theorem that says that if something is differentiable, then it is automatically continuous. However, if something is continuous, it doesn't necessarily mean it's differentiable. And an example of that would be your absolute value function, where you have a corner. At that corner, we have something that is continuous but not differentiable. In any case, for this problem, what we're going to do is we're going to take a look at the continuity, and then we're going to take a look at the differentiability. All right, we're going to look at continuity. Since it's a piecewise function, we're probably going to be more concerned about it being the limit existing from left and the right side. So let's focus on the limits. So let's say the limit as x approaches 3 from the negative side of the function will equal to the limit as x approaches 3 from the negative side of the function. And the function that we want to use is the function out of the pieces here. We want to use the piece where we're going to put in values that are less than 3. So values that are less than 3, we're going to use ax plus b as our function. And if we use ax plus b, this is a polynomial and everything's nice and continuous and stuff like that. So we can just put in the value 3. We're going to get 3a plus b. All right, so that's our limit come from the left. We want the limit coming from the right of the function. And similar thought process here. We're going to take a look at the limit coming from the right, and so we're going to look at the function that takes in values of x that are bigger than 3, and that would be the x squared function. And again, no issues here, no fractions, so we can just put in a 3, get 3 squared or 9. Now that we have these two functions, or these two limits, they're supposed to equal each other for this to be continuous, so we're going to want 3a plus b to equal to 9. Now, we can't do anything with that yet because we have two equations. We have two variables and we only have one equation. So we need to figure out another way to set this up. And so we're going to use the idea that we want it to be differentiable. So to check for differentiability, we can take a look at the piecewise function f of x and take the derivative of that. Now, we already know a handful of derivative formulas, especially with polynomials, power functions and polynomials, and so let's just take advantage of using that. The derivative of ax plus b is a constant, the derivative of that's going to be 0. The derivative of ax is just going to be a times the derivative of x, and the derivative of x is 1. It's like dropping the power 1, x to the 0 power, which is equal to 1. So it's just going to be a times 1. So this is going to be a as long as x is less than 0. And the derivative of x squared is 2x. And this is going to happen as long as, not 0, this is 3. And here, this is also 3. Now, notice that I didn't put equal to 3 here, as it is defined in the function, because we're not sure that the derivative exists yet. And after we take the derivative, or after we figure out and solve for a and b so to make it continuous and differentiable, then we can put the equal sign there. But we need to make sure that it'll work out, it's going to be continuous. Okay, so we essentially want this to be equal to each other at 3. So we can do the limit version of this as well. So the limit as x approaches 3 from the negative side of the derivative, well, this is just going to be a, which is constant, and the limit of a constant is just going to be whatever that constant is. And then we're going to take the limit as x approaches 3 from the positive side of the derivative function that we just found. And that's going to be the limit as x approaches 3 of the second function, 2x. And then we just put 3 in there, and we're going to get 6. So here we're going to get these two things are supposed to be equal to each other. A is equal to 6. So that's already one of the variables that we found. And now let's just plug that back into here. We're going to get 3a, which we said was 6, plus b is equal to 9. So this is 18. So we'll subtract 18 from both sides, and we will end up getting b is equal to -9. All right. So that's it. Therefore, your function, your piecewise function, f of x, should be equal to, it's going to be ax plus b. A was equal to 6, so it's going to be 6x plus b. B was 9, -9 actually, so let's put 6x minus 9. As long as x is less than 3, and then we'll keep the x squared here as long as x is bigger than or equal to 3. And now that we know that a is equal to 6, then we can say, hey, that derivative is actually continuous, so we can put an equal sign on the bottom one since it had an equal sign in the bottom one here. I would encourage you to graph this, maybe use Desmos to graph these two functions and see how they connect when x is equal to 3. First of all, they have to meet there to make it continuous. And second of all, they have to be kind of smooth looking at that point so that the slopes are going to be the same. There's no sharp corners or anything like that. All right. I hope that helps.